So we're going to answer this question before us. It's another piecewise function, but this time we're going to be using our CAS calculator to help us answer it. So we're not going to have to do a lot of things by hand here. It's just going to be using our CAS efficiently. As you can see, we have 3 rules, 1, 2, 3, each with their corresponding domains. I've put a screenshot of the buttons you're going to push on your CAS, but we're also going to do it together right now. So let's come to our CAS calculator. And what we're going to do is there's a couple of different ways we could do it. We could first come to our calculator section, and we could say, all right, I've got f of x, and I'm going to define it. So control this, and then I'm going to hit this button again, and it's going to bring this up for me. Because I've got 3 things that I need to define, I'm going to hit this, and it's going to confirm it's 3. I could put more, I could put less, but we want 3 exactly. Then I'm going to type in what I see here. So I've got x minus 2 squared, and then I have to make sure I also put in the correct domain. So my domain is 0 is less than x, and remember the way that you get those inequality signs is by coming here and going 3. Whoop, that should be a 3. Then the next one is 6, and this is x is greater than 4, and then I've got 4 minus x, and this time it is x is less than or equal to negative 2. And now that's all defined. Then I would come and open up a the graph section here, and then I can just say graph f of x, and you see how it's bold? So that means it's defined, and there it is right there. Now, this is one way of doing it. The other way of doing it is if you hit tab, if you wanted to insert it straight in from here, you would just hit this button here, go there, go 3, and then you could type it in this section here. Really doesn't make a difference. Just your preference, really. So let's now get rid of that. Oh, go away. So get rid of that. That's what we're dealing with. So we've just defined it in the calculator section and then imported it over. All right, now there are a few things that we need to identify here. So let's go menu, let's go analyze, and let's figure out what the minimum is here. So this is negative 2, 6. Menu, analyze, let's figure out the maximum of this point. Menu, analyze, let's figure out the maximum of this point. Just like that. And I know that this is 6 here, so I'm not going to bother finding it because it's just a straight line at 6. Okay, so once we have done all that now, the next thing that we're going to do is come to sketch it. So how am I going to do this? Hopefully you have this open with you. Actually, no, I can just move it across like this. Perfect. Actually, I'm going to do this because it's already right there for me, isn't it? Okay, so this is just where we've got to be careful that we do everything correctly here. So, whoops. And actually, before I do this, let me find out what the minimum here is. Menu, analyze, minimum, 2, 0. So just make sure that you're labeling everything correctly. So I've got a point here at 2, 0. And then it's going to go like this. And I might just spread this out a bit. It's going to look like this. Now this is a closed circle at 3, 1 because I have a less than or equal to, but over at this point this is an open circle, and this is going to be 0, 4. This right here is, as we said, 2, 0, the point at which it touches the x-intercept. I then have a straight line, a horizontal line going through 6. So if I come here, now this is going to be an open circle because it's less than or equal to 4, and it should be a little bit further along. It should be like there. So this point right here is going to be, it's going to be 4, 6, isn't it? Because it's x is 4 and then the y is 6. And then I have another point here. Now this is going to be a closed circle because it's less than or equal to negative 2. And it's going to be negative 2, 6. And this is going to be going up like that. Do you see how, because I don't have a grid, so it's not all ruled up for me, I don't have to be as accurate. As long as everything is labeled correctly, I'm all good. As opposed to when we did a previous question and it had a grid like this. If it has a grid like this, that's when you have to be more precise. But here, this is all good. All right, so I have everything labeled there. That looks all good. So now what I'm going to do is I'm going to state what the range is. So let's state what the range is. What is the range going to be here? Well, I can see that I'm going from 0 all the way to this point right here, which is 4. And I'm not including that 4, am I? Then I've got the union of, do you see I have nothing in this area here? There's nothing there, but then my y values start existing again at 6. And I include that 6 because this point here has a closed circle. So when you've got a closed circle and an open circle, it doesn't matter. You take the closed one because it's saying that point exists there. And then this is going all the way to infinity because this keeps on going up. So that's my range. So 0 to 4, and then from 6 to infinity. So I've got that union symbol there. Perfect. Hopefully you were successful with this question.